So number 49, the chapter 3 homework set, we have a rocket that's launched at a 53-degree angle above the horizontal. So always start with your diagram. And this is a multi-step problem. You're not going to get one like this on the quiz just because it's just, to get to the answer, you got to like calculate this, then calculate this, then calculate that, and then add those three together. It's too many steps for a multiple choice quiz. But this could be on the free response, definitely, because I'm checking your work along the way. Okay, so I'm going to get the diagram set up, and then I'm going to delete this text here because I need more room to solve this. All right, so they tell us that this rocket is launched, and it has an initial speed of 100 meters per second, and it says here that it moves for 3 seconds along its initial line of motion. What does that mean? Is it a projectile yet? No. This is like chapter 2. This is one-dimensional motion. Same thing as a car driving down a straight road. This rocket is going in a straight line, until it reaches this point. Now what happens right here? The engine fails. Uh-oh. I don't want to be in that rocket. The engine fails, and now what happens right here? It becomes a what? Projectile, like a baseball flying through the air. So what we're going to need to find out is what is this starting velocity when it becomes a projectile? What's this velocity right here? So how do we do that? How do we figure out that velocity? With a motion equation. So you know what? I don't think I'm going to show every calculation because we have about 12 minutes to do this, but I'll show this one. The way I figured out this velocity is I just went VF equals V initial plus AT. What's the starting velocity back here? 100. So you're going to go VF equals 100 plus, now what was the acceleration for this first period? 30. And then that lasted for 3 seconds. Okay? So this comes out to be 190 meter per second. That's the velocity of the rocket when it first becomes a projectile. Okay? Now, what are we going to have to do to that 190? The thing that we have to do anytime you have a vector that's not perfectly x or not perfectly y, what do you have to do? Break it into what? Components. Okay, now to do this, we need an angle. What's this angle in here? It's 53, because it's off. This 53 is off the horizontal, and so is this 53. It's the same angle. All right, so that's 53 degrees in there. So now using trig, and I'm not going to show this calculation, but using trig, when you break the velocity up, when you break this 190, you're going to get x velocity as 114.34, and then y velocity as 151.74. Okay, so then the rocket becomes a projectile. From this point, it goes way up like this to the maximum height, parabolic motion, and then lands over there. Okay. Okay, so let me delete the text. So we're solving for 3 things. I'm going to put them up here. The first thing we're solving for is the max height. We are solving for, second thing, total time. Time total from the beginning. Third thing is the horizontal range, which is x. So from here all the way over to where it lands. Okay? So let's delete this text. We're going to need lots of room. All right, one thing that you have to notice right off the bat is that you have 2 accelerations. There's 2 accelerations in this problem. Wherever the acceleration changes, you have to break the problem. So where does the acceleration change? Right there. So the acceleration for this first part was 30 meters per second squared. What's the acceleration for the second part? Well, what do we have to do for the second part? The key thing for projectile motion, here we have projectile motion. The key thing is that we're going to treat the x direction and the y direction what? Separate. So for this projectile motion part, what is the x acceleration? 0. There is no x acceleration because velocity is constant in the x. What's the y acceleration? Gravity, which is negative 9.8. Okay? All right, so let's finish up this first part. So what we're going to need for this first part is the distance traveled before the engine dies. You know, what is this distance from here up to there? What is this straight line distance? So how can we get that straight line distance? I would just use, there's different ways. You could just go x equals 1/2 at squared plus v initial t. Your a is 30, your t is 3, v initial is 100, t is 3. You plug into that and you get 435. So that is the hypotenuse here. That's the straight line distance before the rocket dies. Now, we need this height right here, right? Because look, the first thing we're trying to find is the maximum height. The maximum height is this distance here, all the way. Let's label this y. It's this maximum height right here, from the tippy, when the rocket's all the way up there. Here's the rocket. Okay, so how are we going to find this y? Well, you got to break this into two parts. So the two parts are going to be this part, which we'll call y1, I guess. So how do we find this y1 right here? Trig, right? This is the hypotenuse is 435. Y1 is opposite the 53. So using sine, this y1 here comes out as 347.4. Does that make sense? All this is a triangle. Boom, boom, boom. It's just a triangle. Okay? So that's the first thing. We know the height when the rocket dies. So now we need to find this second height. So let's call this y2, this distance in here. Okay? So how do we find that second height? Well, we got to use a kinematic. The decision you got to make whenever you're doing a two-dimensional motion problem, are you going to solve the question with x direction or y direction? If we're solving for the maximum height from where the engine died, are we using x direction or y direction? Y direction. So to find this y2 right here, I would use, you're going to go vy final squared equals vy initial squared plus 2gy. Now, at the very, very top right here, what do we know? Vy is what? 0. There's no y velocity at the maximum height. So that means we can take this Vy final and cross it to 0, right? And then now take the rest of the equation, solve for y. So I'm doing this one. Y equals negative Vy initial squared over 2g. So it's going to be negative. Okay, what's our starting y velocity? When the engine dies, what was our starting y velocity? 151.74. So you go 151.74. Right, we're using the y velocity over 2 times negative 9.8. The negatives cancel, and you get 1,175. So what will be the total maximum height? You got to add those two together, right? You're going to add y1 and y2 together, and that comes out to be about 1,522. Okay. Wait for that to go away. Okay. So the answer to the first question, 1,522 meters. Okay. All right. Number 2, total time in the air. So I got to clean up some space here. We want the total time in the air. Okay, so again, we got to break this into two parts. We already have the time for the first part. The time for the first part was 3 seconds. Okay, so how do we find the time for the second part? Dude, multi-step problem. This would be too many steps for a quiz. Free response, yeah, because then I could, check your work as you're going. All right, how do we find the time for the second part? From here, so then the rocket goes from this point where the engine dies, the rocket goes boo up here and then back down again. How do we find the time for that? Well, you can do it in one step. You can go like this. You can go y equals 1/2 gt squared plus vy initial t. Now what are you going to get here if you're solving for t? You're going to get a quadratic, which is fine if the quadratic doesn't scare you. I always try to avoid the quadratic, which you typically can. But look, if you're not afraid of the quadratic, what would your y be? What's your y displacement? So here's the starting point right here. Here's the ending point over here. What's your y displacement? Negative 374.4. Oops. Dyslexic. 347.4. It's this, right? The vertical displacement from start to finish is this y1. And why is it negative? Because the rocket went down. Okay, g would be negative 9.8. Vy initial is what? 151.74. So you know what? Let's just leave it at that. I'll tell you how you could have avoided the quadratic, but let's just do this. You're going to get two answers when you do the quadratic. You're going to get one is plus, the other one's minus. Which one is not the answer? The minus one is not the answer. You can't have negative time. And so the positive one comes out as 33.1 seconds. That's the time. That's the time from when the rocket dies to when it hits the ground. So what will the total time be? You got to remember, you got to add what? The 3 seconds. So this is 36 seconds. The total time is about 36 seconds. Now, how could you have avoided the quadratic? To avoid the quadratic, you would first have to come over here and find out what Vy final is. What's the final y velocity when the rocket hits the ground? And the answer is not 0. Oh, when the rocket hits the ground, it stops. No, we mean like right before it hits. So if you calculate that correctly, you'll get negative 172.7 meter per second. So if you can figure out that final y velocity, then you have the starting y velocity, the ending y velocity, and the acceleration. So then you could use, then you could go Vy final equals Vy initial plus GT, and then you could use that to solve for time, right? That's if you wanted to avoid the quadratic. Okay? All right, last question. Oops. Okay, last question is the maximum range. So this is easy. The maximum range is easy because what's the only x equation? There's only one equation for the x direction. So to find out the max, and by the way, we're first finding this. Look at, we're first going to solve for this, right? This distance. So in other words, we're forgetting about part one. So how do we'll call that x1. How do we find from here to here? We're going to use this equation. X equals, so what's Vx? 114.34. And then what's the time we use? Are we using the 36 seconds? No. Nope. The 36 seconds included the first part. So we want to use just the time for the second part, which was 33.1, and then this comes out as 3,784.6. Okay, that's the horizontal displacement after the rocket dies. Now, we have to add on this part. How do we get this part? Trig. So this comes out as 261.8. So then you add that to the other x, and you get a total answer of about 4,046 meters. Dude, that's too many steps for a quiz. Free response, fair game.